Hi everybody, my name is Parker Smith, and today I will be giving my SIP presentation on CForge tutoring, which is a tutoring service that emphasizes teaching game programming through feature-driven design. Here's a quick little bit about myself. I have volunteered and taught in various STEM capacities ever since 2012 when I first volunteered as a teacher for a Best Robotics program in Colorado. For 3 years, from 2014 to 2016, I worked for ID Tech over the summer, and ever since fall of 2016, I've been working as a private tutor in this capacity for a family up in Scottsdale. So real fast, what is CForge? It's what came out of that private tutoring. It is an in-home tutoring service that caters to middle school to high school age students that are interested in getting into game development. I go over the basics of game design and programming, and I like to start projects and see them through from conceptualization to implementation to a finished product. So what makes this innovative? Well, the CForge model is built around something called feature-driven design. Now, feature-driven design is an industry standard methodology that encompasses a lot of core tenets, but the two that I like to focus on are developing a project feature by feature, where the design team works closely with the programming team to make sure that the feature that the programmers are putting out matches the user experience that the designers intended. So I'm sure you're asking, what does that mean in a teaching context? Well, for me, the way I approach it is when programming a feature with a student, it means exploring potential solutions and seeing which one works best with a project design. For example, let's say I'm working with a student on a platforming game, and we come to the point where we're programming how the jump works. So there are a lot of ways we do this. I sort of put down two here. There's like a linear jump where the character moves up and down at the same rate. Then there's a parabolic jump, which is where they slow down at the top and then come back down. These are obviously very different methods of accomplishing the same sort of task. And they will have a profound impact on how the game plays. Not only that, but they are programmed differently. In this way, we would want to evaluate what the final vision of the project is going to look like, as was laid out in the design document when we started the project. And between myself and the student, we would discuss which one of these works best for the project that they're trying to build. So after that, I would ask questions to help the student discover the reasoning behind that design decision, like saying which one of these works better for the purpose of this game, this program. Just say, we want to be critical and say, this is why this works, not just saying this is what works, but this is why this works. Also, we'd want to go over the potential applications of the other methods that we checked out. Like, while the linear jump might not be the best in this specific instance, what is a place where that kind of movement would be wanted? And we would sort of pick that apart and say, okay, while this may not be what we want here, this is still a viable option for use elsewhere. And then also we would just discuss the coding principles that were used in each one and say, why was this effective in this specific application for this feature, and why would the other one be ineffective? Then we would implement this feature, debug it, make sure it's working correctly, get all the kinks worked out, and then move on. Then in subsequent weeks, we would revisit it and check for knowledge retention and see if there's anything I would need to go over again, just to make sure that what's being learned is sticking, that the good practices are staying, that any bad practices are being ironed out. So why is this model helpful? Mostly, one of the things that I learned a lot through the last 5 years is that students like to see the practical results of what they're doing. And in coding, this is no exception. If a student can see why a specific method might work better for a certain feature, then they'll retain that better. They'll remember it better because they got to see what worked and what didn't. It also exposes the student to a broad range of problem-solving methods in programming, rather than just being told one thing that, that's always going to work. it's not always so cut and dry. So it would open them up to a broad range of things that they could use later on. It encourages students to think critically about what they're going through and let them see, okay, programming, this isn't a one-size-fits-all issue. There are a lot of different tools that have a lot of different purposes. So, in a quick recap, the CForge tutoring methodology teaches younger developers about industry standard practices. It aims to increase retention, and it teaches a broad range of programming methods and principles that they otherwise might not be exposed to. It encourages critical thinking and problem solving when they're programming, and most importantly, it'll result in the creation of quality finished products that they can be proud of, that they can put on a resume, all sorts of things like that. And I've been Parker Smith, and this has been my presentation on my SIP project, CForge Tutoring. Thank you for your time.